Alright, this is Webster Grove School District 8th grade Science Foundations Unit and Goal 3. The scientific method. Student is able to design, conduct, and evaluate a valid experiment for any testable question. Alright, so this is going to be looking at, are you able to set up an experiment? And are you able to set up an experiment that would be valid? Okay, so let's look at this. First of all, what is an experiment? An experiment is a way to answer a question by doing tests. Okay? Sometimes we do multiple tests, sometimes we do one test. The more tests that we do, the more valid our results are. So let's look at this question. Does the amount of water affect the growth of plants in centimeters? Okay? So over here we have our parts of an experiment. We have what that is, and I have an example using that question. So an independent variable. An independent variable is the part of the variable that you, the experimenter, are changing. So the change that you're doing and you want to see the effect of. That's the independent variable. I remember independent variable because it's what I am changing, has an I in it. Okay, so that's one way I remember. An example using our question, the amount of water. The amount of water is the independent variable in this experiment. We are changing the amount of water. We want to see the effect. The dependent variable. The dependent variable is the variable that may change depending on the independent variable. I would also add to that it is the variable that you are measuring. Okay, so anytime you're measuring something, that oftentimes is the dependent variable. Can't say always, but often. Example in our question, dependent variable is the plant growth in centimeters. You need to add to that, in centimeters. Okay, so in your notes, you should describe there what's the difference between an independent and dependent variable. Constants. Now constants are important. Constants are the variables that stay the same throughout an experiment. These are important because if you have everything change, or if you have multiple things changing, you don't really know what is causing your results. So you want to change one thing at a time and keep everything else constant. Keep all other variables constant. Example, for our question, we want to keep the soil type the same. We want to keep the type of water the same. You don't want to give one plant Gatorade and one plant Dasani. You know, that Gatorade plant might beat up the Dasani plant. So you want to keep the type of water the same. Also, the amount of sunlight. You're not trying to see how these are affecting the plant. You're just testing the amount of water. But also, your independent variable or your dependent variable cannot be a constant, because those things are obviously not staying constant. They're changing. A hypothesis. A hypothesis is a possible answer to the question. Oftentimes the format is if, and then we put our independent variable, then what's going to happen to our dependent variable. Okay, so that's oftentimes the format that we will use. An example, hypothesis, if Melissa gives more water to the plant, then the plant will grow taller. Okay, so if, and then you have to make an opinion about your independent variable, more or less water. And then you have to make an opinion about your dependent variable, grow taller, grow smaller. Okay, that's a hypothesis. We're taking the word guess, we're taking the word possible or educated guess out of our hypothesis definition, because we're not just guessing, we're using knowledge that we know. Okay, so our format for a hypothesis is if the independent variable does this, then the dependent variable will do this. Now, you don't always have to have it in this format, but you always have to have the independent variable doing something and then the dependent variable responding. You always have to have these two things in your hypothesis. Using if and then is just an easy way to set it up. Okay, but there are definitely more ways you can format this. The question. Okay, so we put it here, does the amount of water affect the growth of plants in centimeters? Okay, we want to say, how does the independent variable affect the dependent variable? Okay, so we can identify this in our question. How does the amount of water, okay, here's our independent variable, affect the growth of plants? Okay, so here's our dependent variable. Alright, so we need to set up our question with the independent and dependent variable in it. It doesn't really matter how you format it. These are two possible formats, but you need to set it up so that it has an independent and a dependent variable in the question. Here's another format. What is the effect of your independent variable on your dependent variable? Just another way to do it. Okay? Now, if a question is not testable, it's going to have more than one independent variable. If a question is not testable, it's going to be something that can't be measured. Okay? So, a not testable. Okay? That would be any question that has more than two or more changes or independent variables. Or maybe it's not measurable. Okay? Now, you have to think realistically, is it measurable? Like if we were going to measure the quality of furniture, well, how do you measure that? That's pretty hard. Maybe that's more based on opinion. Maybe, I mean, there could be hundreds of things you base quality on, so it has to be specific, it has to be measurable. Okay? So these are things you want to watch out for when you're looking at a question, because not every question can be answered using the scientific process, but a lot of questions can. Okay? Watch out for these. Alright, so that kind of wraps up our notes portion. Okay, here's some practice. Will different temperatures affect how many popcorn kernels pop? Okay, so what is different temperatures? We have the options down here. Different temperatures, we're changing that, so that would be our independent variable. Number of popcorn kernels that pop, that's what we're measuring. That's our dependent variable. The type of microwave, the brand of popcorn, the length of time popping, these are all things that could affect our dependent variable. So we want to keep these constant. If popcorn at a higher temperature, if popcorn is at a higher temperature, then more kernels will pop. This is our hypothesis. Okay? And we can identify our independent and dependent variable in that. Okay, so here we go. We have our independent variable. Then we have our dependent variable down here. Let's do one more. Okay, does the maximum size of a bubble depend on the brand of the gum? Okay, so size of the bubble. Is that what we are changing, or is that what we're measuring? Hopefully you said it's what we're measuring. That's the dependent variable. If I chew big red gum, then I'll blow a bigger bubble. Okay, that's a prediction. That's a hypothesis. Size or piece of the gum and the time spent chewing, these things have to remain the same. These are constants. The brand of the bubble gum, this is what we're changing. Okay? Alright. So that wraps up our notes for this section. Thanks for watching, and we're out of here.